graphing radical functions. We left off with, we were talking about moving this point up here. Instead of going up 1 over 1 to get the next point, we went up 2 over 1. Why do I choose 2? Because that's your vertical stretch. That is your vertical stretch. So then, really, if you do your vertical stretch as 2, if it does have a vertical stretch, you don't need to draw the third point. Just draw your new graph. It's going to be higher than f of x because of that vertical stretch. So again, what vertical stretch means is here's your function, and the vertical stretch just takes it and it moves it up further. So it gets higher faster, basically. Okay. Now, let's think about domain and range of g of x. It looks like the green function, the domain still starts at -1. So that's our domain. It's the same as f of x. And what about the range? The function starts at y equals 3, and then goes up forever. So, you know what? Vertical stretch doesn't affect the domain and range. It just affects how fast it starts to go up. So, if you had a vertical stretch of 3, you expect the graph to start going higher even faster. Vertical stretch of 4, even faster. It would go same shape, but just it's going up faster. It's like shooting up at a quicker pace. All right, this is the last one. So I just showed you square root functions. I just got to show you cube root functions. So I'll do this in purple. We have graph f of x is equal to the cube root of x minus 2, state the domain and range. So minus 2 is on the inside of the radical. So that's our h value. So h lies. So we would think it moves left 2, but really, because it lies, we have a shift right 2. K, there's nothing out here. That means there's no up-down shift. So we're not going to be shifting up or down. And then there's no a value here besides 1. There is a 1 here, but because there's no other number, there's no vertical stretch. So this should be a relatively easy problem. Ooh, this dot right here is from the previous paper. It must have bled through, so ignore this dot right here, okay? Let's go ahead and graph shift right 2. So remember what the original graph looks like, or the parent function of cube root. It looks like this. So our starting point is still the origin, 0, 0. So we're starting at 0, 0, but we have a shift right of 2. So we're at 0, 0, but now we're going to go right 2. And then we check, do we have any up or down shift? Well, this problem doesn't. If it did, we would keep going. We wouldn't stop here. But because we don't have an up and down shift, we only have a shift right 2. Here's our point. Now, if you look at these other 2 points, let me show you the reasoning here. I'm going to actually show it like this. I'm going to fold this over real quick. The point that's in the middle right here, the one I'm pointing to right now, this one, and this purple point I just drew, they're identical in what they mean in the graph. And then I want you to see that if you look at the parent function, how do you get from here to here? You just have to go up 1 over 1. So we want to do the same thing here. We're going to go up 1 and over 1. And then to get this other point that's down here, if you're at the middle of the graph, you go down 1 and to the left 1. So we're going to do that here as well. Down 1, left 1. And if I just go by the shape of this graph, just the best way to draw it is pretend like you're drawing the square root function that we just learned about. So like this. And then do it again, but you're going like a sloping downwards angle like this. And there you go. So that is your cube root function. And then your domain and range. So remember with cube root functions, this one's covering the whole x-axis. It's going to go left and right forever. That means our domain and range domain is all real numbers. But in the same logic, this is going down forever. It's going down forever, and this part's going up forever, which means our range is also all real numbers. Again, I apologize about the break in the videos. I'll try not to do that again. And thank you for watching. Make sure to like and subscribe.